Okay, so we're going to focus on day 2 notes and just pay careful attention so that we can make sure that we're getting all of the required information on this. All right, so take 2. All right, this is day 2 notes. We're going to focus on our terminology and some basics when it comes to drawing some angles and some circles and so forth. So first, we're going to talk about 3 different circular angles and standard position, meaning that measuring 215 degrees, 575, and negative 145. But as we draw these, I want you to pay close attention to the details that we're going to put in each picture. So I want you to notice 215 degrees. So what I'm going to do is when we go to draw, the first thing you want to do is put a ray of some vocabulary from geometry. Put a ray on the x-axis. This will always be the case. You always want to start at the origin and draw your arrow to the positive x-axis. And then 215 degrees means we're going to go, this is 90, this is 180, this is going to be 270, and if we come back around, it's 360. So if we look at 215, we notice that it's a little bit more than 180 degrees. In fact, it's 35 degrees more than 180 degrees. So that means we are ending in quadrant 3. So we take this ray, and we're calling it a terminal ray because that's where it terminates. And we always have to make sure we draw from the original ray and put an arrow indicating the direction that we're going. And then we can put a little bit of extra information in terms of from the 180 degree mark, it is 35 degrees further. All right, so that's how you're going to draw a 215 degree angle or any other angle. You make sure that you have those components. Now let's take a look at 575. I want you to notice that 575 is more than 360 degrees. So we need to figure out where that is. So let's go ahead and subtract 360 degrees. That means we're going around 1 time. And then we've got 215 degrees left, which means we now need to draw another 215 degrees. Well, we already know that 215 degrees ends in quadrant 3. So what we're going to do is the first thing you do, now watch, even though it's already done, I want you to watch as I draw. You're going to start at the origin and draw a positive x-axis. Step 1. Step 2 is to figure out where this is going to end. We know that 215 degrees ends in quadrant 3. So I'm drawing my terminal ray. I'm also putting this reference because it's a 35 degrees more than the 180. But when we go back and we draw our angle of rotation, we're going to start at this positive x-axis and we have to go around 1 whole time. That's 360 degrees. And then now we draw the 215, going quadrant 1, quadrant 2, ending in quadrant 3, and we put an arrow. Now let's take a look at negative 145. So if you notice the negative, that's going to go clockwise. Okay, notice on all of the other ones, we started and we went around counterclockwise. So 145 degrees is going to be, let's take a look. You always start at the origin, positive x-axis. We've got 145 degrees. So we know that this is 90 degrees going from here to here. And if we were to figure out how much it is from, there's a couple ways you could do this, but we always like to put the reference angle in terms of the horizontal axis, so the x-axis. So I've got 145 plus 35, and that's going to be taking me to 180. The other way to do this is 180 minus 145, and then that's going to give you 35 degrees, which is why we are putting 35 degrees here. We know that it's going to be 35 degrees short of 180. So I'm putting my terminal side here, and because it's negative, I again start at the positive x-axis and add your angle of rotation and put your arrow. All right, so what do all of the angles drawn above have in common with each other? So go ahead and answer that question. All right, so same initial side. That's a vocabulary that I was using when I was explaining those. The initial side is the positive x-axis. The terminal side is where you finish ending up. So you could be in any quadrant or any axis, but it's the ray that you draw where you end. And then we've got a reference angle. And so the reference angle is the positive, and it needs to be the acute. So not only does it have to be the positive angle, but it has to be the acute angle that the terminal side makes with the x-axis, which is why I told you up here, we always want to go to the horizontal x-axis. It's why I didn't put a degree mark over on this side. Okay, so we always want it to be the reference angle to the x-axis. All right, what is one difference that all of the angles drawn above have? Okay, so figure out if there's a difference. All right, so if I take a look, there is the difference is in the arrow of rotation. Okay, which tells two things. Number one, it tells the direction of the rotation. If it's positive, it is going to go counterclockwise, and if it's negative, it's going to go clockwise. And then it tells us the number of quadrants the terminal side passes through. So if I take a look at this, we know that this went around 360 degrees and then plus a little bit more. And we ended up in the same quadrant, but the angle of rotation told us how many more times around we had to go through. All right, so based on what you've seen so far, what are the four vital things that all circular angles must have when you draw them in standard position? See if you can figure out what that is. Okay, so number one, well, you always have to have an initial side. So it's always going to be the positive x-axis. Always got to have a terminal side. Remember, that's where it ends up. You always have to have the arrow of rotation, and then you need to label any reference angle, right? So, continuing, the three angles that we drew above are called coterminal angles. So we need to give a definition of coterminal angles. So what do you think coterminal angles are? Okay, so here we go. Coterminal angles are angles that actually terminate in the same position. Okay, so here is the word terminal, like your terminal side. Remember, every angle had a terminal side, and co is going to mean with. So they terminate in the same position, but and they have the same reference angle, but they have different arrows of rotation. So notice that this reference angle was 35 degrees all the way across, but the angle of rotation was different. This angle of rotation only went through 3 quadrants. This one went through 4, 5, 6, and 7, and this one went through 2. Okay. So now you're supposed to draw negative 470 degrees in standard position. So do that on your paper. Then find one positive and one negative coterminal angle with negative 470 and draw them in standard position. Okay, so when you drew your negative 470 degrees in standard position, what did you find was your reference angle? All right, so let's take a look and see how well you did. So if I'm going to draw negative 470, first of all, I'm going to go clockwise. And I also know that it's more than 360 degrees. So what I want to do is take 470, not the negative just says clockwise. 470 minus 360, and then that's going to give me 110. So that means I need to draw 110 degrees from the negative position. Okay, so 110 is slightly more than 90 degrees. So let's take a look at what I'm going to draw. All right, so as I draw this, I've got my first one is the initial side. I know that I am going to end up at 110, but I'm going clockwise. So 110 is a little bit more than 90, right? So from here to here is 90 and a little bit more. This is going to be 20 degrees more, right? So 90 here, 20 here. So that means it adds up to 110. That's my terminal side. Okay. I use that to help guide me. If this was 20, remember that I have to have my reference angle to be to the x-axis over here, which means this is going to be 70 degrees. So I'm going to get rid of my 20. And then remember that it was a negative, so I have to start at the positive x-axis, but I'm going clockwise. So I go around once and then 110 degrees. Okay, so that's what you should have drawn. Now, to find a positive and negative coterminal angle, we need to make sure coterminals, we end up at the same spot, which means we're going around one full circle. How many degrees are in one full circle? Okay. All right, so now to find a positive, I'm going to take my negative 470 degrees and I'm going to add 360. Well, when I do that, I still end up with negative 110 degrees. So I need to add another 360. So I know that I'm going to have to add 360 twice. Now I could do that one at a time, or I can go 2 times 360 because I'm having to go around twice. And then either way, that's going to end up giving me 250 degrees. So if I were to draw 250 degree angle, let me do that right now. Again, when I draw my 250 degree angle, I've got my positive x-axis. 250 degrees is in quadrant 3. This right here is 270 degrees, so 250 is right here, and it is 70 degrees more than 180, okay? So then there's my reference angle, and then remember it was a positive one, so it's from the positive x-axis going counterclockwise. So this would be my positive standard position. Now negative, I've got negative 470 degrees. I want another one that's negative, so I'm just going to subtract 360, or I could have subtracted 360, or I could have added 360, and the only reason why I could have added 360 is because when I add it one time, I still get a negative number. So sometimes you're either going to have to add or subtract 360 degrees to find positive and negative coterminal angles. So if I were to draw my negative 110 degrees, I take a look at this. Again, the first thing I draw is the positive x-axis. Negative 110 is slightly more than negative 90, which means I'm here. I'm going this direction, and I know that it's 70-degree reference angle. All right. So from here, it says, just as segments can be measured using inches or centimeters, angles can be measured using different units of measure. In trigonometry, 2 units used to measure angles are degrees and radians. Super, super important. We spend most of our time dealing with radians. So once we get past this introduction to degrees and radians, we're going to mostly focus on radians. All right. So radian measure is based upon what is called the unit circle in trigonometry. So by definition, the unit circle is a circle whose center is at the origin and whose radius is 1. So now, if we were in class, we would do a little activity where we actually derive the radians, but for right now, this is what we're doing for distance learning. So find the circumference of the unit circle. Well, we should know that the circumference, which is the perimeter, it's the outside, right? The outside part of a circle is 2 pi times the radius. But if your radius is 1, then that means the unit circle has a circumference of 2 pi. Okay, so the distance all the way around is 2 pi. So what must a 360 degrees be multiplied to obtain the circumference of the unit circle? Okay, so if I were to take 360 degrees, so 360 degrees says by what must 360 degrees be multiplied? So times x to obtain the circumference of the unit circle. The circumference of the unit circle is 2 pi. So what we have to do is now divide by 360 degrees. And so x is equal to pi over 180. So basically that's the same ratio. So let's take a look at what this means. If I were to go in degrees, and this is important, I want you to write this down. If I were to go into degrees, this would be 0, 90, I'll put the degrees on the inside, 180, 270, 360. In radians, again, it's the same measure, just a different terminology. We use like comparatively to inches or centimeters, we've got radians and degrees. So we know that the circumference is going to be 2 pi. So what we're doing is dividing up this circle in terms of pi's. So if this is 2 pi, this is 1 pi. And half of pi is pi over 2. So let me put my radians on, you could put 0 pi if you would like, then pi, and then this is half pi over 2. So we've got 0, 1 half, 1, 1 and a half, which is 3 pi over 2, and then 4 pi over 2 is 2 pi. Okay, so just kind of catching up here. Pi is the same thing as 180 degrees. One is in degrees and one is in radians. In order to establish which one is which, you have to have the degree symbol. So if it does not have a degree symbol, it defaults to radians. So here's what we're going to do. We're going to make sure that we know how to convert from degree into radian measure. So you have the degree times pi over 180. So remember, you've got the degree. You've got a degree. When you multiply them, you want those degrees to cancel. And so that way you end up with radian measure. So to convert from radian measure into degree, so you starting off with radians, right? You need to end in degrees. So your degree must be on top, and your pi most likely will end up canceling out. Not always, but it will mostly, and then that's going to give you degree measure. So if you want degree, your degree must be on top of the fraction. If you want radian measure, your pi must be on top. Your degrees have to be on the bottom so that they cancel. All right, so let's take a look at this. Please do A, B, C, and D. All right, 90 degrees. So what we're going to do is take 90, multiply it by pi over 180, because we're trying to get rid of those degrees. And then we got 90 pi over 180, and now I can reduce, and I get pi over 2. All right, so negative 235. Remember, I want to cancel out the degree. So degrees have to be on the bottom. And so I cancel that out. And then now I just simply reduce. Okay, now notice we do not have a degree symbol, which means it defaults to radians. So that means my 180 degrees needs to be on top. I'm going to multiply, but I can go ahead and cancel those out. And then I can go ahead and reduce. This gives me 60. And anyway, it ends up simplifying to 120. And then on D, again, I have a radian measure. I'm going to go to degrees, which means my 180 is on top. My pi is on the bottom. I can cancel those out. I can actually reduce and then finish multiplying.